続きまして、インフラ監視における ALOS-2 の役割と題しまして、3V ジオマティクス社プレジデント、エイドリアン・マッカードル様よりご講演いただきます。Mr. McCardle, the floor is yours.
Thank you. And I'll try to speak slowly because I was struggling to understand some of the Japanese translation there. So, but I'm also happy to answer questions afterwards. But thanks very much for having me here today to talk about ALOS-2. It's very, very much appreciated. I'm Adrian McCardle. I'm co-founder and president of 3V Geomatics. And as we as a company, we work on a single thing, and that's INSAR. I know the previous speaker talked a lot about INSAR, but we use INSAR more for looking at smaller features, landslides, subsidence, buildings moving, pipeline monitoring, and things like that. That's the sole purpose of our company. We've been around since 2007. We're about 60 or 70 people based in Vancouver, but we do have some offices worldwide. And most of our business is outside of Canada. It's a global business. So we are also now part of a larger group. So we work with RST Instruments, Measurand, Navstar, and Syscom. All of these companies primarily make instruments that monitor ground displacement. So we're very, very complementary with this. We know our technology and all remote sensing technologies are not the full solution by themselves, but they work in conjunction with surveying or other instrumentation. In March of this year, we became part of the Orica group. Now, this company was founded 150 years ago by Alfred Nobel, who also better known for the Nobel Peace Prize. So the interesting part about being part of this company is we're now with a company called Ground Probe, who do a very similar technology, sometimes the same technology as us, using radars on the ground. So they can point those radars onto a mine slope or a landslide area and monitor much, much higher frequency than we can, but very, very complementary technologies again. So today I'm going to talk about how we're using ALOS-2. And first I'd like to say thank you to JAXA for ALOS-2. It's an amazing sensor, and we've done it's done so much, and it's helped us really help our customers and our users a great deal. And there's a couple of things. I'll start with an example that we've got. It's one of the ones that really started our company working a lot more with L-band data, and we'll talk about this specific example because it's an example where we would never have been able to have success without an operational L-band satellite. So I'll also talk about a couple of key factors for us as a company, what makes it successful in an L-band project. So we had a customer who had a huge area of pipeline network that they wanted to monitor. It's about 30,000 square kilometers. So we worked with JAXA and with ResTech to select 8 separate footprints in Alberta to monitor this area. Now, this is Alberta, so we have a lot of snow in Canada, and so we were expecting between 10 and 15 3-meter strip map images during the snow-free periods a year. Now, I want you to keep in mind, this is not Alberta where you see Banff and the big tall mountains. This is relatively flat terrain, but geohazards are still a big problem in these areas. So slow-moving landslides can cause a lot of problems. So why are we using INSAR here? Why are we using L-band? So I'll say L-band was used because this is the type of customer before ALOS-2 where we would have had a great meeting with the customer. We would have discussed what do they need for their monitoring, and then we would have told them, no thank you, we can't monitor. C-band is not good enough here. X-band is not good enough here. The results are going to be too marginal. So there isn't any other solution other than L-band. So geohazards in Canada are a huge problem. They're a huge problem everywhere. Now, for pipeline operators, they're less than 10% of the problems that they have with their pipeline. However, the type of problems that they cause are outsized. They're very big. So they cause safety, environmental, economic problems. And when a problem happens because of a geohazard, it tends to be extremely large. So our customer and another operator in 2016, they had a pipeline running, and the pipeline ruptured because of a small landslide. The oil spilled into the Saskatchewan River, and it caused an enormous problem. It cost about $160 million to clean this spill up. Now, that was only the economic cost. We have to also factor in the reputational costs for this company. So the reputation went down, and also there is a social license for pipeline operators and any mineral extraction that, this starts to break that social license. And as in most parts of the world, and Canada is no exception, building a new pipeline is extremely controversial, and these types of incidents, they really get people upset and they want to fight against the pipeline. So we've got to help prevent these types of incidents. There was another landslide that happened in northern Alberta near Fort McMurray in 2020, and after this pipeline or landslide occurred, they were assessing the damage to the pipelines, but the price of oil jumped up at this point. It can have such a big impact. So these are the types of things that we're trying to prevent with active, proactive monitoring. Because when we're monitoring these types of areas, the typical way is people are walking the line using visual inspections. We can have drones flying, we can use optical satellite data, but essentially the biggest thing people are spending money on is a problem occurs. So it's big enough so somebody can see it with their eyes. So maybe there's some cracks on the ground. And at that point, sometimes it's too late to take some mitigation measure. These usually cost more. Maybe a problem with the pipelines already occurred. So that is a reactive way to monitor or to handle the problem. We use ALOS-2 to be proactive. We want to see those movements before they become a big problem. In a vegetated area like we're talking about here, we can usually get between 1 and 4 centimeters of precision. So that's pretty high precision. We can see often the movement and risks before any big problems occur. In Canada, we've got 850,000 kilometers of oil and gas pipelines. Now, this is not something you can walk regularly along the pipelines and look for these types of risks. It's an enormous network, and it's a potential for disaster if we're not monitoring properly. And that's where ALOS-2 comes in. So for this customer, we implemented a monitoring program. And the goal of this monitoring program, as with most of our monitoring that we do, is to identify new displacement, a new potential risk to the pipeline, something that they didn't know anyway. So we would have high frequency of reports during the critical period. Was when it was a wetter period, when the snow is melting. There tends to be a lot more geohazards, a lot more risk to the pipeline. So our frequency of reporting was extremely high. As I said on the previous slide, we plan to have between 10 and 15 images of each footprint during the snow-free period. So that's about May to November, maybe October, depends on the season. And we used some displacement detection algorithms that we have at 3VG because the risk of having a high number of false targets really can limit the benefit of the technology. So we look at the signal to noise of each area of displacement. We compare it to its neighbors and say, okay, in this area here, what are the conditions for INSAR monitoring? Do we have high precision, low precision? And it's a very adaptive. So in some areas with a lot of noise, our thresholds are much higher versus areas where it's a low noise, where we can be very confident. But we want the user to be able to identify those risks with confidence. If we show them that there's displacement, we want them to have high confidence that they can go to the field and investigate this. So we can also provide to that customer a time series analysis, which is very common with most INSAR monitoring programs. So that gives that user also the ability to look at a little more detail for each target, that they have all of their monitoring areas so they can see what's the history, what's the background for this point. It's not just what happened in the last 1 or 2 images that were required, but we want to see, is there a long-term trend that's happened here? because the way this typically works with this type of customer is we will monitor and we will generate a report showing all the areas of displacement, particularly areas of new displacement or accelerations. We send that to the operator who works with a consultant, and that consultant can determine, an engineering consultant saying, this is an area that I've got to go investigate. We can take this action. Maybe they put an instrument in the ground. Maybe they just continue with the INSAR monitoring, but they make a determination of risk. And this type of tech can really help them. So in 2019 with this customer, we identified an area on the North Saskatchewan River, and we could see that there was some displacement starting to happen. You can see it, I think this is working here. In 2019, we can see there was definitely movement here, and it was clearly flagged. Now, if you look at the top right image that we have there, that's sentinel results over the same area. And you can see over all of the critical parts of the area that we want to monitor. Oh. And so this is the 2019. You can see the flat part of our time series. The flat part here was during the winter where no data was collected. So here we can see all along the riverbanks and some of the critical areas here, we have no data with Sentinel-1. It's just showing you how ineffective the C-band is in this case. Sentinel is a great satellite, but when you start mixing it with vegetation, it's unreliable. You cannot get good results. Now, the ALOS-2 data that we had, and this is the 3-meter data, it was great. We were clearly able to identify the areas of movement here. We could see that the movement started in 2019, but you can also see in 2020, once the spring, the thaw happened, you can see an acceleration of displacement. So for the geotechnical engineer, this is a big risk. So they went investigated this area, and they could see there was clear cracks, evidence of a landslide, and their decision was to shut down the pipeline. Now, shutting down the pipeline is also an extremely expensive thing, but they judged that the risk of a rupture and a failure of that pipeline was much, much higher than the cost of replacing that pipeline and putting it into a different area. So for us as a company, this showed us how effective ALOS-2 can be in an operational scenario. We're really helping people out with this. There was no other solution for them. No other technology was able to identify this risk because, like all remote sensing, we're able to see a huge area and we can get down to some really good details. So this was a big win for us, and it really, really made a big difference with our customers in seeing the value of using the L-band data. So I want to talk now about a couple of the factors that are really important when we're judging the success of using L-band data. So the two factors for us, by far the biggest is resolution. Resolution is really critical, having a good resolution. Primarily, we're using 3-meter strip map ALOS-2 data when we're using L-band, and it makes a big difference for us. And I'll show some examples in a second. I'll talk about another factor as well, but I want to also highlight that we're moving into a period, ALOS-4 is going to come online and provide data. We're also going to have data from NISAR, hopefully starting sometime next year, we can say. And this is going to be great. They're going to provide a lot of great information for us. But when we look at NISAR collecting data, 7, 8 meters around the globe, this will be a very, very powerful tool, but it doesn't replace what we're able to do with ALOS-2. Now, the examples I'll show, we're fortunate, we're working in an area in a tropical equatorial region that we had SAOCOM data at 10 meters, and we had also had the ALOS-2 data being acquired for a customer. So it gives us a very good head-to-head comparison. Unfortunately, we have a lot of great results, like a lot of you, but we're not always able to share everything that's interesting because the results do belong to our customers. But this is an example we can share here. So here we have SAOCOM on 10 meters. So this area here is highlighted in red. It's a well-known movement area in this region. So we were comfortable, we knew that it was there moving, and we also had another slope that came down here. Now the customer knew all about that. We're using instruments, we're using INSAR, we're monitoring it very closely. What the customer wasn't aware of until we started using ALOS-2 was there was another additional landslide there. Now you can see there's not much explanation here. With 10-meter data, it doesn't exist. With 3-meter data, it does exist. So this is a big difference when we're looking at these types of, the impact that we have from ALOS-2 and the ability to get data from high resolution sources. So yes, we're going to use NISAR a lot, but no, NISAR would probably not be successful, even though it is a little bit better than SAOCOM in this case. Here's another area. We can see a single road. In remote areas, often single road is the only access point. And we see the results from SAOCOM, and there's an area of displacement, not adjacent to the road, but not too far from the road. But when we start using the higher resolution data, we can see that it's actually incorrect with SAOCOM. But with greater detail, we can see those displacement areas adjacent to the road. And that's creating a different risk profile for the geotechnical engineers. They can see, hey, this is something we have to worry about today. This is a very high risk to our people here. We move to another area here, and this is in a community. Number of people, again, very remote, a lot of vegetation. So this is the SAOCOM results. Everything looks great with SAOCOM, there are no issues. And then we move to ALOS-2, the higher resolution. There's 2 areas right inside the community that are moving. And geotechs went to these areas and they said, yes, these are real areas of movement. We have to install some instruments. And they would not have known possibly till it was too late without the use of ALOS-2. So the second big factor that we've got is the frequency or the number of images, the reliability of acquiring data. So you can see through the graphic that I've got here. So we can run through all the way between 3 and I think we get to 21 images, 23 images. And so the first few images, unless something is moving extremely rapidly, there's so many noise factors for us. We're not able to confidently say, this is displacement, this isn't displacement. But when we start adding those images up, we can start really removing the noise. We can remove noise like soil moisture. We can remove noise that might be caused by the elevation errors in our processing. And we can start really identifying where the motion is versus where it's not. And again, having that confidence with people. So getting data reliably and consistently, multi-years, we're able to see displacement that occurs only seasonally. We're able to isolate that as noise and remove it from our analysis and really give the customer a much better product. So extreme example of that is we have a current project we're working with JAXA and with ResTech on, and we had our biggest stack ever. I think we had 63 images acquired here, and this is in an area in Brazil. You can see some of these motion areas. Now I can tell you if we only had a dozen or 15 images, we would not have any confidence to say that, hey, these are movement areas. There's millions of people live along this pipeline and the slopes that we monitored here, and we could very effectively see where the movement was and where it wasn't. Now this was a special place for me. I didn't know when we kicked off the project. It was actually an area that I visited in 2005 when I used to work for McDonald Detweiler. And it was fascinating for me because we tried to monitor INSAR here with C-band, with RadarSat-1. We went there, we had a very expensive campaign to install corner reflectors, and bottom line, it just didn't work. We got some okay data from the corner reflectors, but then you change that to an L-band and you change it to high frequency, a big stack of data over multiple years. We're able to get very high precision, reliable data, and we can really make an impact with people. So for us as a company, ALOS-2 has been critical. We've been able to help so many of our customers. We've got over 50 customers around the globe that are impacted by ALOS-2. It's a unique monitoring solution. Almost everywhere that we're using it, there's no alternative. There's no X or C-band alternative, and it's probably unfeasible to survey or do ground-based techniques. We have 250,000 kilometers of coverage that we're monitoring, square kilometers of coverage that we're monitoring, and we're impacting tens of millions of people. I know that the usage, commercial usage of ALOS-2, it's a small fraction, but I also know that the impact that it's having outside of that for the users and the people that are impacted, it's enormous. Tens of millions of people are impacted when we're keeping those areas we're monitoring safe. It makes a really, really big impact. So that's a big factor for us, being able to get access to data like this as we continue. It will continue to have a huge, huge impact. That's it. Thank you very much.
Thank you for your presentation, Mr. McCardle.